We are recording now. This is Wednesday, the 17th of December, Algebra 2 at WSSB.
Eric's birthday.
Eric's birthday?
Yeah.
Is Eric in this class? Oh, okay. Yeah.
Erica, but not Eric.
Yeah, I was like, what?
I'll take his birthday for him.
What? I'm confused.
Erica, when's your birthday?
Next month.
Alright, we need to be on page 209. Find find where it says lesson by lesson review 4-1 introduction to matrices. So it's probably 209B or C.
209.
I thought we were going to practice a couple more problems because we only need one.
Oh, did we? Okay, well, we will. We'll throw it in here today.
Review, so whatever.
I wanted to give us 2 solid days on the review.
Yeah, no, that's cool. I'm just
And then, yeah, we'll get there.
It'll be in there. So.
JJ,
Yes.
will I be able to pick up the test before I leave tomorrow?
Yes.
Yeah, we'll decide on the numbers. Today.
Yep, we will. All of them. All right, page 209.
She wants the whole book done by the end of the day.
4-1 introduction to matrices. What is it in? Is it on B? Is it on C?
I'm still looking.
Maybe on D.
Maybe
That's it.
Maybe that's the grade I have in this class, but hopefully not.
4-1 intro to matrices.
Lesson by lesson. It is on D.
It is on D. Okay, so D, 209 in Braille. All right.
Does that make grade?
No, I don't think so.
I'm thinking English, maybe.
Yeah, probably.
Everything, like,
You can check
all
it.
my classes are like solid
Skyward's.
B's. Like, that's so stupid.
I can check your grades.
I know,
Alright.
but they're all like solid B's.
That's
B's.
good. Oh, zero matrix one.
So we're gonna go way back to when we started all this matrix madness.
Oh god.
All right, we're going to start the review. My objective is today and tomorrow. I know we meet on Friday, but most likely Friday's going to be a
Nothing day.
nothing day for the most part. My objective is for us to get through the review together mostly, or at least like really get a good grasp of it, because you're going to be allowed to take this volume home with you over the break, and you may use the review as a reference. Okay, so if we go through it together, you're familiar with it, and then you know you can go find key information in the review to help you with your exam questions. Okay? So, intro to matrices, it says that a matrix is a rectangular array of variables or constants in horizontal rows and vertical columns. Equal matrices have the same dimensions and corresponding elements are equal, right?
Mm-hmm.
So they give an example. We started out, remember way back when this matrix stuff was really easy? It looks like we have a 2x1 there, doesn't it? And it says 2x over y on our 2x1, right?
Mm-hmm.
And then that equals,
Fudge.
and then they have a matrix 30, what are you doing? Oh, you're looking for paper? Okay. 32 plus 6y, and that's over 7 minus x. And this is a 2x1 and a 2x1, isn't it? You can have an element be an expression.
Oh, sorry.
So we can have an element just be the 2x, that term, or we can have an element be an expression, the 32 plus 6y. The corresponding elements are the 2x to the 32 plus 6y, aren't they?
Mm-hmm.
And the equals in between, we could rewrite that out. 2x equals 32 plus 6y. And we could then write out y equals 7 minus x, couldn't we? So we could write these as linear equations. And then we could do our linear equation, system of equations rules to this without matrices, just the stuff you learned back in chapter 3. We could, because it has y equals 7 minus x, we could plug that 7 minus x in for x, couldn't we? Solve it, or in for y, I mean. Solve it for x, and then substitute that in and solve for y. So that very first section was mostly about reminding you that you can set up a matrix, an element for element corresponds to each other, and you could then solve it using your system of equations rules from the previous chapter. We need to practice that.
One problem.
You want to try one problem?
Yeah.
All right, fair enough. So let's go down to find number 11. Mm-hmm.
Because the way you explained it was a little odd.
All right.
I think I might
It
have-
was so long ago, before Thanksgiving.
It was.
We spent 2 months with just this chapter.
Sort of, not
It
quite.
was the
I mean,
longest.
we take a week out of there. We've gotten through 4 chapters in 3 months. That's pretty good.
You knew about an average of a chapter and a half month.
Mm-hmm. And this month is missing a
This is
couple
really important
weeks.
for future math.
Yeah. All right, so we have number 11, you have an open bracket, 2y minus x, close bracket, and then a row down, open bracket, and x. So your matrix is a 2x minus x for your first element,
equals 3.
and then, yeah, and that's going to equal 3, you're right. Because your second matrix has a 3, and then it has a 4y minus 1.
Yeah.
So your first equation, if you rewrite it out, is 2y minus x equals 3. And your second equation is x equals 4y minus 1. Now, because they were nice enough to say x equals, you can use the substitution property and substitute in the 4y minus 1 for your x in your first equation, can't you?
Mm-hmm.
So you should have 2y minus 4y minus minus the quantity of 4y minus 1 equals 3. So it's actually, if you were to write it out, to be very careful with it, you would write 2y minus open paren 4y minus 1 close paren, because we have to be careful that it's minus the quantity, which means it's going to be a negative 4y, and then minus a minus 1 becomes what?
Plus 1.
Plus 1. So we have 2y minus 4y. What does that simplify to? Nope.
Negative.
Negative 2y. And then plus 1
No, that's
equals 3. So negative 2y plus 1 equals 3. Then you're going to subtract 1 from both sides. And you're going to get negative 2y equals 2. Y is going to equal negative 1. Good job. Now you take that negative 1 and plug it back in to any one of the equations. I would plug it back into the x equals. So 4 times negative 1 is negative 4. Negative 4 minus 1 is negative 5. So x is going to equal negative 5. So there's your solution, negative 5, negative 1. I would plug it back in and check it, right? And camera keeps wanting to adjust weirdly here. There, sorry about that song. So if we plug in negative 5 for x equals 4 times negative 1 minus 1, yep, negative 5 equals negative 5. If we plug it into our first equation, 2 times negative 1 is negative 2, minus a minus 5, minus a negative 5. So negative 2 was plus 5. That would be 3. 3 equals 3. So they check, don't they?
Mm-hmm.
It's always a good idea to check. Isn't usually any reason why you should get algebraic equations wrong if you check them.
Why is the song so quiet?
Why is song so quiet? He muted himself so that we wouldn't hear the motorboat.
Hi, motorboat song.
What's that?
We had to find a solution for using the test.
Yes. All right.
Yeah, but there's 3 ways to do it in this chapter, isn't there?
Mm-hmm.
Elimination, substitution,
No.
All right.
Last time.
and
So what do you
matrices.
think? Is that all right? That brings back some chapter 3 stuff. That one was, we could substitute. We could do another one. You want to do another one when we need to use elimination?
No,
Okay.
no.
Let's do number 13.
Grape.
So find 13.
Grapes are good.
All right.
Me too. I haven't eaten
3x
all
plus
day.
y equals
Okay, 3x plus y equals negative 3
Oh, there it
on
is.
number 13.
Yeah.
Mm-hmm. And then x minus 3y equals negative 1.
X equals 2.
So 3x plus y equals negative 3. And you'd write this down. Write it as a system. And then x minus 3y equals negative 1.
You said 3x plus y equals what?
3x plus y equals negative 3.
You need to Sharpie or something?
And x minus 3y equals negative 1. So what do you want to multiply by to do you want to do elimination?
Yeah.
So which one would you like to eliminate, your x's or your y's? The y's. So we're going to multiply our top equation by a 3, aren't we? So we're going to rewrite below our 9x plus 3y equals negative 9, right? And we need to add these together, right? Because a negative 3y and a positive 3y, those are going to cancel, aren't they?
Yeah.
So x plus 9y is, or x plus 9x is 10x, and negative 1 plus negative 9 is negative 10. All right, so if 10x equals negative 10, what are we going to do? Divide by 10. So negative 10 divided by 10.
Negative 1.
So x equals negative 1.
Same as before almost.
Oh, I know.
But
Yeah.
imagine if y equals 5. Negative 5.
Yeah. All right. Now, plug that in, right?
Mhm.
Go up to either equation. 3x plus y equals negative 3, or x minus 3y equals negative 1. Well, so what is 3 times negative 1?
Negative 3.
Negative 3 plus y equals negative 3. How do you get rid of the negative 3?
Right.
Add 3, right? So what is negative 3 plus 3? 0. So y is going to equal 0.
So close.
So double check it. In the other equation, if x is negative 1 minus 3 times 0, negative 1 equals negative 1, right? So your solution set would be negative 1,
Gotta check that one.
1,
zero.
Gotta check
0.
the other one.
3 times negative 1 is negative 3, plus 0 is
Okay.
negative 3.
I've
Alright.
done that. Gotten the one right.
Gotten the one right, not the
And then
other.
that one wrong. Oh.
Alright. So you just did, using a matrix to set up the system of equations, solve the first system of substitution because it was nice enough just to say x equals. And then you solved the second system using elimination. Alright? So it makes you practice the stuff you learned in the last chapter. Alright, ready to move on to 4-2?
Just wondering, why does it have to be in a matrix anyway? Because why don't they just write it out in the system?
It's just foundational song. It was the very first example of what a matrix looks like for you guys in the first section. Now that you've used matrices, for weeks, you're looking back at this going, well, that's just silly. Why did we even do that? But it was just an introduction to that an element of a matrix equals an element of another matrix. Okay?
Okay. Alright.
So let's move on to 4-2. And it discussed, now remember in 4-1 it also discussed, rows by columns, right? How you do your dimensions, and you're really good at that now. Okay. So matrices can be added or subtracted if they have the same dimensions. Add or subtract corresponding elements. To multiply a matrix by a scalar of k, multiply each element in the matrix by k. So 4-2 was very basic with how do we add and subtract matrices, how do we do a scalar of a matrix, not multiply the matrices, but do a scalar. So they said in example 1, can you find that, where it says A, matrix A minus matrix B? And matrix A is a matrix, what's the dimensions on it?
It's a 2 by
2 by 2, and what's the dimensions on B?
2 by 2.
So we can do this, can't we? And matrix A has a row 3, 8, and a row of negative 5, 2. And we're going to subtract matrix B with a row of negative 4, 6, and 1, 9. So element to element we subtract. So what are we going to subtract? 3 minus negative 4, right? Element to element. So that's going to be a 7, okay? And then your second element on your first row, 8 minus what? 6, good. which is 2. So you're going to have 7, 2 in the first row of your difference matrix, your 2 by 2. And then your second row, negative 5 minus 1, negative 6, and 2 minus 9, 2 minus 9, and that would be negative 7. So your matrix, your answer should be 7, 2, negative 6, negative 7, right? Okay. So pretty basic. Don't we wish we could just don't we wish we could just add and subtract all day long with matrices? Yeah, it'd be kind of boring.
It's kind of weird. You have 7 and then negative 7 and then diagonal.
Oh. So. Oh, on the diagonal. Yeah. All right. Let's move on now then to the next example. It is doing a scalar. And it says if X, matrix X, what's the dimensions on matrix X?
That's
2 by 3. Good job, Angelica. So we have 3, 2, negative 1 in our first row, and 4, negative 6, 0 in our second row. And they say find 4X. So we're going to scale it 4 times. We're going to quadruple it. Everything times 4.
12.
So that's right. 12, 8, negative 4. Good. Your first row. Second row.
12, negative 18, 0.
4 times 4 is 16.
16.
4 times negative 6,
Negative
24. And 4 times 0, 0. Good. So you have a
Negative 12.
16, negative 20, 16, not negative 16, 16, because it's 4 times 4. And then negative 24, and then 0. Right? So just doing scaling. Watch your negatives, right? Could we have a scale that is fraction? Yeah, of course, right? We could, yep, so you could do that, right?
Nobody likes determinants. I do. Well, they're easy, but
So how do you feel about section 4-2?
pretty good.
Okay. All right. So first section, of course, you're going to have some questions on the test where you solve systems. As Song said, why the heck did they even put them in a matrix, right? Let's just make us solve a system. They're just getting you familiar with what a matrix looks like. So you'll have a question or two on your exam. That's tapping into your knowledge and practice from the last chapter, which is good for you. All right?
Well, that was the chapter that I had to test that for.
Yes. And then the next section, it was just noticing that you got to have the same dimensions on your matrices if you want to add or subtract them. So you always check that. If they're not the same dimensions, you say no soul, right? You can't do it.
Nope.
Then if you're going to add or subtract it, all you do is just element to element. So that's where you're really paying attention to those positives and negatives, especially if you got a minus in between them, don't you? Get a minus negative, you got to remember to add. And then finally, then in that section, you did scalar. That's just distributing that scalar, that scale multiplication to every element and being really careful with your positive and negatives and lining those rows up right. Okay? Moving on. What do you think? Seems like so long ago, huh? All right, 211, 4-3, multiplying matrices. This is where it started to get a little crazy, huh?
Oh, jeez. See pages 167, 174. Concept summary.
When we started the chapter, you were
Two
going to
matrices
Vegas.
can be multiplied if,
And we didn't do anything.
and only if the number of
Columns.
columns in the first matrix is equal to the number of rows in the second matrix.
So the very first thing you had to learn was you had to list out your dimensions of your matrices and make sure the two middle numbers are the same, right? So if we have a 1 by 3 wanting to multiply a 3 by 2, is that possible? Yes. Because 1 by 3, 3 by 2, you've got the same number of columns as you do rows in the separate matrix, at 3 and 3, right? So we can do it. And what is our answer matrix going to end up being? it's going to be end up being a 1 by 2, isn't it?
Yeah.
Yeah, because you'd have the outside elements determining that, all right? So we do have a 1 by 3 and a 3 by 2 here as an example, don't we? We have, it says find xy. So find matrix x times y. X is a 1 by 3, so it is a 6, 4, and 1. Right? Just one row, 3 columns. And it's going to multiply a 3 by 2. The first row is 2, 5. The second row is negative 3, 0. And the third row is negative 1, 3. Okay, so this is an example in 4-3 on page 211. 2, 5, negative 3, 0, and negative 1, 3. Okay. So how do we multiply? Row by column. Okay, so what do they mean by that? So we take this row 6, 4, 1. We multiply 6 times what? Nope. 6 times 2. Then what do we do?
Then becomes next one with a row.
Nope. 4, we add, right? We go plus 4 times what? No, negative 3, because it's row by column, right? And then we do plus 1 times what?
Negative 1.
Negative 1. Excellent. Okay.
No.
Do you see now? So then, so we have to,
Time.
we go times plus times plus times, right? So 6 times 2 is 12. Plus 4 times negative 3.
Negative 12.
So 12 and negative 12 is 0. Plus 1 times negative 1. Negative 1. Negative 1. So our first element on our product matrix is negative 1. Yep. All right. Now we do the row by the second column, don't we? All right, so what are we going to multiply? 6 times what?
5.
5 plus 4 times 0. Well, what's that? What's 6 times 5?
30.
30. What's 4 times 0?
0.
So we're at 30 so far, aren't we? Plus 1 times 3.
30.
So 33. So our second element is 33. So our answer, our product matrix is negative 1, 33. That's it. Because it just is going to end up being a 1 by 2, right? All right. Try it again. All right. Well, that's because you guys have been doing it a lot.
Yeah.
We have to multiply when we do other things too.
One we did like a month ago.
No. Well, you did, yeah, and you did systems quite a while ago too. All right, let's try another one. Let's try number 19.
Yay.
So we have, what's our first matrix? What's the dimensions? It's
a
a
1
2
by
and a
2.
7 in it, and it's a 1 by 2. Okay, 1 by 2. What's our second matrix?
2 by 1.
2 by 1. Can we do it? All right, and what's our answer? 1 by 1, isn't it? Just going to be
Yay.
one little element, isn't it? All right. So we have 2, 7 in our row of 1 by 2. And we have a 5 over a negative 4 in our 2 by 1. So we need to multiply these, and our answer matrix is just going to be one element. So what are we going to multiply?
10.
2 times 5 is 10, plus
Negative 28.
negative 4 is negative 28. What's 10 plus negative 28? Negative 18. All right. Don't we wish they were like that all the time?
Yes.
All right. They're not, though. Let's jump to 21. Let's take a look at 21.
Oh, hi.
Find it?
That's like a 3 by 2.
It's a 3 by 2. Okay.
And then a 3 by...
3 by 3. Is a 3 by 2 multiplied times a 3 by 3 possible?
No.
Why, Angelica?
Because the 3 and the 2 don't match up.
Correct. We have 2 columns in our first matrix and 3 rows in our second matrix. Those do not match up, do they?
Nope.
So, or excuse me. Yeah, 2, 3. There we go. Those inner numbers, if you wrote it out, 3 by 2 right next to 3 by 3, the two inside numbers have to match, and they don't, do
We
they?
can do the next one.
So we say not possible on this, right? Okay. We can do the next one. Let's do that. All right. So 22, we have, what's our dimensions?
2 by 3.
2 by 3.
And a 3 by 2.
And a 3 by 2. Okay, so it does work.
So we'll have a 2 by 3.
Nope.
Other
We'll have a 2 by 2.
2 by outside.
Outsides. Okay. All right, so our first matrix, 2 by 3, our first row is 3, 0, negative 1. And our second row is 4, negative 2, 3. You see that?
Mm-hmm.
That's going to times by
7, 1.
first row is 7, 1. Second row is 6, negative 3. And third row is 2, 1. Now, when you're doing these, you can utilize your book. You don't need to rewrite these matrices. You can just utilize your book and go row by column. But then when you write it out, you need to write out your answer matrix, right? Your product matrix.
Mm-hmm.
Okay, so our first row is 3, 0, negative 1. And our column on our second matrix is
7,
6, 2. Good. So 3 times 7 plus 0 times 6. That's just going to be 3 times 7 is 21 plus 0 is 21. All right, and then negative 1 times 2
Negative 2.
is negative 2. So what is 21 plus negative 2? 19. Good. So the first element, when you go to write your answer, first element on your product matrix is 19. All right, we're still working with the first row, aren't we?
Mm-hmm.
Now we got to work with the second column. What do we got to do?
0.
3 times 1, good, Angelica, is 3. Okay.
Plus 0.
0 times negative 3, so plus 0, plus negative 1. All right. So what's 3 plus negative 1?
2.
2. Good. So your second element on your product matrix is 2. All right. So there's your first row. Okay. Now we want to go do our second row.
4, negative 2, 3.
4, negative 2, 3 times 7, 6, 2. All right. What's 4 times 7?
28.
28. What's negative 2 times 6?
Negative 12.
28 minus 12.
Plus 6.
16. All right. And then plus 6. That's what Erica's saying. 22. Do you get 22, everybody? Okay. So 22 is the element on the first element on your second row. All right. And now you got to do that second row, second column, right? All right. 4 times 1 is 4. Good. What is negative 2 times negative 3?
6.
4 plus 6?
10.
10. What is 3 times 1? What's 10 plus 3? 13. Your final element is 13. So you should have a product matrix that is 19, 2, 22, 13. Okay.
Transformers.
Transformers? Is that what you said?
Yeah. I was looking.
All right. So, what do you think about multiplying matrices? You getting it down? It's matrix work is darn camera keeps wanting to adjust. It keeps thinking it needs to go to the left or the right. I don't like the auto adjustment. All right. What would you say you want to tell yourself about multiplying matrices?
Don't get your rows and columns confused.
Don't get your rows and columns
Keep your
confused.
hands on the book
Keep your hands on the
for
book.
braille users.
Okay.
Otherwise, you would get really off track.
And for print
Mhm.
users, keep
Don't
your eyes
get your
on the book.
negatives confused, Nancy.
Yep. Don't get your negatives confused. Keep those careful and straight. Good.
Something else for positives.
Positives also. Yep. Multiplying matrices is just an exercise in being careful, in my humble opinion. Right? I mean, it's
Which
not.
is really important before you do math.
Yeah, it's not really hard, but if you're not careful, you will end up in a land of lostness. Yes, no return. When you start to get some complex, linear algebra kind of stuff going on with matrix work, if you make one little mistake with the basics, you end up in a land of yikes. Yeah. All right. And my linear algebra teacher in college didn't let us use a calculator for the entire course. Entire course.
Then I started to love Eigenvalue.
Yes. Yes.
That's because you started playing it.
All right. Let's look at 4-4. This takes us to, okay, we've learned to add, we've learned to do scalar, we've learned to multiply. Now, why are we doing this? And this is the transformers, the transformations, right? So let's review our transformations. There are 3 styles of transformations. What's one of them? One of them is a reflection. Okay. What does a reflection mean?
It's basically a
It
mirror image.
flips. It's a mirror image, and it's flipping over some line. So typical, it's flipping over the x-axis, the y-axis, or the x and the y-axis. But we could also throw up another line that it flips over. We didn't do that in this chapter. They were nice to you, but you could have any line that it flips over. Okay.
Rotation.
All right. What's another one? Rotation. A rotation is not a slide.
Translation.
A translation is a slide, yes. A translation is a slide, and it can slide up, down, left, right.
And vertical.
Vertical, horizontal, on a diagonal. Rotation means it does what? It turns.
There's also one called dilation.
Aha, yes. Thank you. There's more than 3. You're right. Dilation. What's dilation mean?
To expand.
Yeah.
Good teamwork there.
It's scale. It gets smaller. It gets larger. Good. Good job. Remember the dilation. I'm sorry about that I blurted out there's 3. All right. So let's take a look at our concept summary on 4-4 on page 211. Now that we reviewed the different ones. It says use matrix addition and a translation matrix to find the coordinates of a translated figure. Because addition means that's what it's doing. It's just moving over, right? So addition and subtraction would mean that it's sliding back and forth. So that's why we use addition with our matrix work, to just slide our figure. We use scalar multiplication to do what?
To
Multiply the matrix, and so if we scale it, what's the it's going to dilate, isn't it? It's going to become bigger or smaller with our figure. Okay. To reflect a figure, we're going to multiply the vertex matrix on the left by a reflection matrix. So remember, this is where, hint, hint, hint. So page 211, section 4-4, they give you the matrices that you need to use to do the reflections. So if you're going to reflect over the x-axis, you use 1, 0, 0, negative 1.
Correct.
That's over the x-axis. Okay? If you're going to reflect over the y-axis, you're going to use negative 1, 0, 0, 1, right? And we practiced this. We put them on graphs and saw what was happening, right?
Mhm.
And then if you reflect over both the x and the y axis, so it goes a flip, flip, right? You're going to use 0, 1, 1, 0. Okay? So you might want to remember that is there for you when you go to answer a question about reflection in your test. And if it says reflect this image over the x-axis, you're going to go, oh, what do I need to use? You can go look at that. All right? You could derive it if you thought about it. But, all right, to rotate a figure, you're also going to need these 3. To rotate a figure 90 degrees, so you're going to turn it about a point at a right angle, it would be 0, -1, 1, 0. To rotate it 180 degrees, you're going to use -1, 0, 0, -1. And to rotate it 270 degrees, or how Song likes to turn it, go the other way 90 degrees, right? You're going to use 0, 1, and -1, 0. Okay? So if you're answering questions that say rotate this image, this pre-image, 90 degrees, then you're going to, and it's all counterclockwise. So,
you have what to do.
right there, yeah.
If you don't realize that now, well, nothing I can do.
So there is a demonstration, you're right. Let's take a look at that. It says find the coordinates of the vertices of the image of PQR with, it's on the thermofilm. P is 4-2, Q is 6,5, and R is 0,5. So they've got plotted on the graph. And it says rotate it 90 degrees clockwise about the origin. So you're going to use your 90 degree 0, -1, 1, 0 matrix, and you're going to multiply it by the points. So notice how they put the x's in the first row and the y's in the second row, right? So 4, 6, 0, 2, 5, 5. So you're going to do row by column, right? 0 times 4 plus -1 times 2. That just flips it. Remember, you learned, you did this a few times and went, oh, check that out. My y's flip up and become my x's, x row, and they become the opposites. And my x's flip down and become the y row and just stay the same. So your transformation matrix is -2, -5, -5, and 4, 6, 0. So then you plot those points, and bing, you have rotated the figure clockwise. All right. Okay, so you'll have some of those. You can refer back to this section, all
And if
right?
you don't remember which side your transformation matrix goes on, just check the dimensions. A 2x2 and a 3x2.
Mm-hmm.
And you can figure out what's place. Is it on the left or the right? Because again, matrices are not commutative.
Not commutative. All right, that's enough for today. Tomorrow we'll do determinants, Kramer's rule. See how far we get. Maybe do identity and inverse. And then Friday we'll finish up with using matrices to solve systems, and then have some fun. All right? All right. I'm going to stop the recording.
You still have Wi-Fi?
Get out.
I don't know.